Section 5.5, Properties of Quadrilaterals. After studying this section, you'll be able to identify some properties of parallelograms, identify some properties of rectangles, identify some properties of kites, identify some properties of rhombuses, identify some properties of squares, and identify some properties of isosceles trapezoids. Looking at properties of parallelograms, in this section we'll list some of the properties of special quadrilaterals, beginning with parallelograms. Now we should be able to prove many of these properties. Read the properties carefully and learn them. They'll be used often in the sections to follow. First, looking at the properties of a parallelogram. So in a parallelogram, the opposite sides are parallel. So PL would be parallel to AR, and PA would be parallel to LR. The opposite sides are also congruent, so PL would be congruent to AR, and LR would be congruent to PA. Then the opposite angles are congruent, so angle PAR would be congruent to angle PLR, and angle ARL would be congruent to angle LPA. The diagonals bisect each other, so segment AL would bisect PR, and PR would bisect AL. So if I have a point in the middle, call this point E, then this segment would be congruent to this segment, and this segment would be congruent to this segment, because if I'm a bisector, I split into two congruent segments. And lastly, any pair of consecutive angles are supplementary, because if I have parallel lines that are cut by a transversal, this would create same side interior angles, which are my consecutive angles. And if I have parallel lines, then same side interior angles are sup. So for instance, angle PAR would be sup to angle LRA. I can have many different pairs of consecutive angles in a parallelogram that would be supplementary. Next, we'll look at properties of rectangles. So in a rectangle, all the properties of a parallelogram apply by definition. So the opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, the diagonals bisect each other, and then any pair of consecutive angles are sup, as well as all angles are right angles. So this angle would be a right angle, this angle would be a right angle, this angle would be a right angle, and this angle would be a right angle. And then my diagonals are congruent. So diagonal ET is congruent to diagonal RC. Now looking at properties of kites. So in a kite, two disjoint pairs of consecutive sides are congruent by definition. Disjoint pairs meaning that one side can't be used in both pairs. So IT would be congruent to ET, and then IK would be congruent to EK. The diagonals are perpendicular, so TK would be perpendicular to IE, meaning that they form right angles, so all four of these angles would actually be right angles. One diagonal is the perpendicular bisector of the other. Remember, perpendicular bisector is the segment that is perpendicular and bisects another segment. So if TK is the perpendicular bisector of IE, that would mean these would be right angles, as well as this segment would be congruent to this segment. One of the diagonals bisects a pair of opposite angles. So if we were to say that ray TK bisects angle ITE, it would mean that this angle is congruent to this angle. And we could say that ray TK bisects angle IKE because it's pairs of opposite angles. So this angle would be congruent to this angle. And lastly, one pair of opposite angles are congruent. So in this kite, angle TIK is congruent to angle TEK. Now, properties 3 through 5 are sometimes called the half properties of kites because it refers to half of the diagonals or half of the pairs of opposite angles. Now looking at properties of rhombuses. So in a rhombus, all the properties of a parallelogram apply by definition. So again, the opposite sides are parallel, the opposite sides are congruent, the opposite angles are congruent, the diagonals bisect each other, then any pair of consecutive angles are supplementary. All the properties of a kite apply, and the half properties of a kite actually become full properties. All sides are congruent, so a rhombus is equilateral. So side MO is congruent to side OH, which is congruent to side HR, which is congruent to side RM. The diagonals bisect the angles, so both pairs of the diagonals bisect every angle. So ray RO bisects MRH, ray RO bisects MOH, etc. Both diagonals are perpendicular bisectors of each other, so they form right angles as well as split the sides into congruent pieces. And then the diagonals actually divide the rhombus into 4 congruent right triangles. So if I were to split my rhombus into 4 different right triangles, all of these triangles would be congruent. Now looking at our properties of squares. In a square, all the properties of a rectangle apply by definition, and all the properties of a rhombus apply by definition. So we would have opposite sides are parallel, all sides are congruent, all angles are congruent, the diagonals bisect the angles, the diagonals are perpendicular bisectors of each other, and then the diagonals form 4 isosceles right triangles, or 45, 45, 90 triangles. 45, 45, 90 triangles are a special triangle that we'll learn about in later sections. And lastly, looking at properties of isosceles trapezoids. So in an isosceles trapezoid, the legs are congruent by definition. Remember, the legs are the sides that are not the parallel sides. So TP would be congruent to RA. The bases are parallel. Remember, the bases are the sides that are the ones that are parallel. So TR is parallel to PA. The lower base angles are congruent. So angle TPA would be congruent to angle RAP. The upper base angles are congruent, so angle PTR would be congruent to angle ART. The diagonals are congruent, so diagonal PR is congruent to diagonal TA. And then any lower base angle is sup to any upper base angle. So angle PAR could be sup to ART or PTR. Looking at our sample problems, we have problem 1. We have the following givens, and I want to conclude that segment GH is congruent to segment EF. So segment GH is this segment here, and EF is this segment here. Notice these segments are part of triangle GHA and triangle FEC. So if I can show that these two triangles are congruent, then these two segments will be congruent. Now let's look at our givens and then mark our diagram. So first we have ABCD as a parallelogram. This can tell me lots of different things, so we'll come back to this one. Angle GHA is congruent to angle FEC, so this angle is congruent to this angle. And then side HB is congruent to side DE. Now, based on the definition of a parallelogram, I know that opposite sides are congruent. So side DC would be congruent to side AB. Well, if I have two congruent pieces of this side, I could use the subtraction property to show that side AH is congruent to side EC. Now I need another angle to prove my triangle is congruent by angle side angle. Well, also, if I know in a parallelogram that the opposite sides are parallel, I could say that side DC is parallel to side AB, or side AD is parallel to CB, and then cut those parallel lines with the transversal AC, which would give me these angles congruent, angle GAH congruent to angle ECF, because those are alternate interior angles. Now my triangles are congruent by angle side angle, making my segments congruent by CPCTC. So listing these in my statements and reasons, I'd have my first given, ABCD is a parallelogram, then DC is parallel to AB, or I could say AD is parallel to CB. Opposite sides of a parallelogram are parallel. Then angle ECF was congruent to angle HAG, because if I have parallel lines, then alternate interior angles are congruent. Then AB is congruent to DC because opposite sides of a parallelogram are congruent. Then I had my third given of HB congruent to DE. Then I used subtraction property to show that HA was congruent to EC. Angle GHA is congruent to angle FEC was my second given. My triangles were congruent by angle side angle. And then GH is congruent to EF by CPCTC. Looking at problem 2, we're given that VRZA is a parallelogram and expressions for each side. I want to find the perimeter of VRZA. So I know that in a parallelogram, the opposite sides are congruent. So if I label each side with the expression, then I can set up equations to solve for x and y. If AV is 2x minus 4, VR is 3y plus 5, RZ is a half x plus 8, and then ZA is y plus 12. I know that AV is congruent to ZR, and then VR is congruent to AZ. So 2x minus 4 equals half x plus 8, and then 3y plus 5 equals y plus 12. Solving for x here, I'd get 1.5x equals 12. Divide by 1.5, which would give me x is 8. And then 3y plus 5 equals y plus 12 would give me 2y is equal to 7. So 1y is 3.5. Now taking my x and y values and plugging them back into my original expressions, AV is 2x minus 4, so 2 times 8 is 16, minus 4 would give me a side length of 12. AV is the same as RZ, so that is 12 as well. And then VR would be 3 times 3.5, which is 10.5, plus 5, which is 15.5. So VR and ZA are 15.5 each. 12 plus 12 plus 15.5 plus 15.5 would give me a perimeter of VRZA of 55 units.